Hi all, today's topic is central limit theorem for a problem 3. The lifetime of a particular variety of electric bulbs may be considered as a random variable with mean 1200 hours and standard deviation is given to be 250 hours. Use the central limit theorem. Find the probability that average lifetime of a 60 bulbs exceeds 1250 hours. So 62 1250 hours. Okay, exit means it is greater than. Question it is asked 60 bulbs given. N is given to be N. It is given in the question to be 60 bulbs. Okay, mean it is given in the question E of X to be 1200. They did not mention which distribution and all. So 1200. Standard deviation it is given to be standard deviation 250. Then it is the question it is asked probability of whatever that. Okay, so Sn it is asked to be greater than, exit means it's greater than 1250. So what is the probability it is asked in this question? So now check my previous video. I have done with the same concept only with the formula different set. Now different set. We have a two set of central limit theorem definition. Two form or two author has been derived. The same concept are same. Only slight difference in the formula. You can use both. When which we have to use means in that also we can apply this. When I'm going to apply this means when it is a large sample, how you decide upon it is a large sample means when the data given are very large. For example, it may be a mean or it may be a n. Okay, sometimes n may be a large 1000 or more than 500 like that, or mean may be a 4-digit number. Okay, so any one it is large means you have to go with this method only. Whatever I'm doing in the third problem, that method I have to do. I've done already two problems in my previous video. Check that in the video. I've done only slight change. So what is the change also I will tell in this. Now I'm going to use a central limit theorem. With the following normal distribution mu and sigma by n. Okay, already in previous video I followed with, I will write it here because I'm not normal distribution followed with n mu and n sigma square. I've used this set of formula only. I have used this format only. I have used. Now I'm going to use because very large. When here also large. Okay, here only n is 60. But sometimes when I multiply both, okay, if I use this means n into mu, I have to multiply n. Mu is this, n is this. When I multiply, I'm getting more than 5 digits or 6-digit numbers. So this will be difficult for my calculation purpose. So I'm not going with that method. My previous video like that method I'm not going. So I'm going with this format. I'm not multiplying n. So that reason only. So throughout the same, why I'm saying it is the same procedure only. You check in this. I don't have n. I'm going to remove n means throughout I have to divide it by n. So you divide it by n means small n. When I do it, what will be mu comma sigma squared by n. So that only I told it is the same only. It is not a different method. Okay, slight adjustment only. So that only I am going to do normal distribution with respect to mu comma n square divided by n. When I multiply it, when I get a large n into mu, when I multiply it, I get a more than 5 digits, 6 digits, 4 digits. So I am going with this method. Okay, there is no rule at all. Only this you have to do, that you have to do. You can do it. Okay. So now normal distribution of mu comma sigma squared by n. So standard normal variate will be x bar minus mu divided by sigma divided by root n is the format. So now when I convert it, all the data are given directly. We can convert it. Probability of Sn minus mu divided by sigma divided by root n throughout the equation. Subtract it with mu divided by sigma by root n throughout. So that is the understanding. So it is greater than 1250 minus mu. Mu is nothing but this is mu. E of x is mu. So 1200 divided by sigma is nothing but standard deviation is sigma 250 divided by root of 60. So do this calculation. This fully is nothing but Z. So this fully is Z. So probability of Z is greater than, so calculation when I do 50 divided by 250 divided by 60 is nothing but 1.55. Immediately you have to draw a rough diagram for this. Then only you know where is the region. So 1 point means it is some here 1.55. So greater than 1.5, the region will be this. So the region is like this, means how we have to do, how we know that half of the diagram is 0.5. Remember, when you check in my previous unit video, normal distribution, check the video, then only you can understand this concept. So minus 0.5, 0 to infinity is 0.5, minus of 0 to this data, when I calculate, I will get Z greater than 1.5. So probability of 0 is less than Z is less than 1.55. 1.55 you have to see in the table value. Table value when I check, already table value, this is our table value 1.55. I have to check the table value. So in the check the table value 1.55 means under 1.55. Both add 1.55. So correspondingly data 0.4394, 0.4394, 0.4394. I will underline where it is 0.4394. Okay, so that data only. So subtract it 0.0606. So completed. So this question was find the probability that average lifetime of 60 bulbs exists 1250 hours is 0.0606 is my answer. Fourth problem. The burning time of a certain type of a lamp is exponentially random variable with mean given t. What is the probability that 144 of this lamp will provide a total of more than 4500 hours of a burning time? So now, what is the question given? Mean, we know that mean of exponential distribution is 1 by mu. So everything mean is given to be 30. Okay, mean is given to be 30. Mean in the question given to be 30. Okay. Variance then, so variance we know that it is nothing but mean is 1 by lambda as per the exponential distribution. This we have studied in the second unit. So variance is nothing but 1 by lambda squared. So the whole squared, it is same 30 means whole squared. So 30 the whole squared. Okay. So 30 the whole squared is nothing but 900. So mean is given to be 30 and variance is given to be 900. So what is your n? N is given in the question to be 144. So now first we will calculate n mu. N mu is 144 into 30, multiply it 4320. Same way n into sigma squared. Variance is nothing but sigma squared. So n is 144 into 900. So I'll be getting 129600. So now convert it. So what is the question it is asked? So probability total of more than 4500. So probability of Sn is more means greater. So greater than or equal to 4500. 500. Now convert it throughout, subtract it. So Sn is subtracted with n mu divided by n sigma squared. So same way is greater than or equal to 4500 minus 4320. So divided by n root of n sigma squared. Okay, root of n sigma squared. So this separate root you take it, that is easy for my calculation. Like way you can take it. Okay, so when I take it, 900 root is 30, 144 root is 12. So 12 into 30, so it is 360. So this fully is Z. Probability of Z is greater than or equal to, do the calculation of this. So when I do a calculation, it's 0.5 I'm getting. So immediately after this, you draw a rough diagram under here itself, 0.5. It's greater than or equal to 0.5. Somewhere here 0.5 means our region will be, this is our region. Like this you have to draw it. So it's 0.5. So 0.5 means subtraction is nothing but 0.5 minus probability of 0 is less than Z is less than 0.5. 0.5, see the table value. Only 0.5, so 0.5 at 0. 0.1915. 0.1915. Subtract it with this. So 0.3085. So completed. This is our final answer, 0.3085. Thank you.